week one. Today we're going to go through DNS enumeration. So it's about taking a domain and enumerating all the subdomains before it. Essentially, what we're going to do today is we're going to be enumerating subdomains based off the domain, but I'm also going to explain the whole DNS system in itself. So a protocol would be something like HTTP.
Which stands for?
Hypertext Transfer Protocol.
Thank you.
Subdomain could be like mail or www.mail. Domain could be something like Yahoo. Top level domain would be .com. And the root is, like, if you go to your web browser and type in a web address and just put a dot after it, the same thing happens with not putting a dot after it, because that's how the DNS system works, which I'm going to explain now. So at the top of the DNS is the root server. So we'll start from the top. So your machine will connect to a DNS server, and the DNS server will usually be given out by your IP address. So they cache DNS records, essentially. So we start at the top with root, and coming from root is all your top level domains. So we're working backwards. We're going to start with root, go to top level domain, then domain, subdomain, and protocol. So from the root, things like .com, that's a top level domain.
Just reiterate what the root is.
So
The root is basically just a dot.
all around the world there's root servers, and root servers dish out the top level domains, or their zone is the top level domains, and from then downwards. So when you register a domain with something like GoDaddy or something like that, they register it with the top level domain, and that's why you can access it. So .uk is another one. That's a country code top level domain. This is a top level domain. Another one would be something like .org. What else we've got? So .com. Yeah, .com, .uk, .org, .net. We'll just go for them. So from .com. So this is the roots zone. Oh, I didn't put zone on there as well. Zone. So yeah, so the root server contains all the information about all the top level domains. So that's your first point of call whenever you put in a DNS request through your browser. So we'll go for .com, we'll go Google, and Google. I'm going to use my own website because I'm going to use this quite a lot in this.
Bit of marketing there,
yeah, a little bit, yeah. Google, what was else we're going to put in here? So in the .uk domain is things like .ac, .co would be another one, and .gov is another subdomain of AC. .org, I'm just going to put off there, Wikipedia. I'm just giving you like examples of them first before we go into anything else. So Google, what subdomains does Google have? Does anyone know what subdomains Google has?
Subdomains don't.
Search engine software?
Oh, what, sorry?
Search engine?
Yeah, so search engine is what? What would come before Google if you were going to search something at Google? There you go. So www, so that's their web service. So www, it's part of their web service. You go www.google.com, and then if you put a dot on the end, it would also go to the root server. So they have other things like docs, images,
Maps.
Maps, yeah, that's a good one. Google Maps. Room security, I've got a mail, so I've configured a mail server on my website, and I've also got www, Yahoo. Login is also a domain. Login, www. They're all going to have www because they've all got web services in front of them, so they're all running web services. .ac, so you could have things like T's, which is obviously where you are right now. .gov, so you could have things like local councils, local authorities, so it'll be like Reading, and you could also have Leeds. Reading, yeah. Leeds, because I used to work for Reading Council, so. .co, so I'm running out of space here, but say like BBC, that's a domain of .co, and then obviously Wikipedia is .org. We'll leave .net, we don't really need .net. So, because it's top level and you're working from right to left, we started from the root and we went to the top level domains. They're the top level domains, so that's what the root deals with. So the .com server, or the .com domain, that's the .com zone. Obviously there's millions and millions of websites in there. Same for .uk, so that would be UK, Let me see. .gov, that's its zone, because we're going to explain zone transfers. .org. Yeah, we'll just try and draw something around that. So that's how zone. Yeah, so are you starting to get in how it works, how the structure works for domain systems? So it's all hierarchical. So we're starting with root, top level domain, and then of course Google's domain, all of these subdomains reside in it. Mail was part of that one. Where there? Yeah, www. This is all like important terminology, that's why I'm trying to cover it. You get the point, so we'll go Reading. So they're all the zones. So it's hierarchical, it'll always pass it down to what it knows. So if you're going from root to top level domain, the top level domain servers are going to pass it down to the domain servers. I'm going to explain that on the other board. And then domain servers will pass it down to the subdomain services. So does that all make sense? And each of them, they can only deal with what's in their zone. So Google will only, the Google domain, so or Yahoo domain for instance, will only pass it to the left. It'll only pass it to the subdomains. And then obviously the protocol is irrelevant, but that's obviously part of, still you have to use it as part of the DNS query. All right, so now I'm going to explain how a DNS query works. So everyone get how that works, though, yeah? How the DNS systems, it's all hierarchical. So a DNS query, start with your PC. I'm going to draw a lovely PC. So that's your PC, and that's a DNS client, because that's waiting for the result of your DNS query. So it's a DNS client. So inside your machine, you have a hosts file, which is like the local operating system level hosts file. Host file is configurable, and it can also be spoofed as well. It's gone from the ISP to the root server. The root server said, I don't have an IP address for root security. Try the .com server. So it's come back, and it said to the .com server, do you have an IP address for www.runesecurity.com? Comes back and says, I don't have an IP address, but you can try the rune security domain. So let's get rid of this a second. So here we go. So this now is going to the rune security domain. Security. So again, it's going to ask the request. Do you have a? I'm just going to put quotation marks there because I don't really want to send the same request off. Do you have an IP address for www.runesecurity.com? And it says yes, I do have an IP address. And it's, I don't know, 20.1.2.3. And then obviously it's going to send that back to the DNS client. So do you get how all that's working, the whole query system? From client to the ISP. And what the ISP does is when it gets that address back, I will put that in there actually. So yeah, DNS client to the ISP. The ISP then sends a request to the root server. The root server sends a request back to the ISP saying, I don't have it because it's not in my zone. I only deal with top level domains. Send it to the .com server. .com server responds and says, I don't have the IP address, but you can try the name server for Rune Security. So it goes down here to Rune Security. Rune Security goes, yes, I do have a web service running www. So it sends that IP address back to the ISP. The ISP will then just store it in its cache, so it doesn't have to go through all of this again. It can just go straight back to it, and then it gets sent to the client. So is that fully, yeah, everyone understand that? So now what we're going to do is go through brute forcing subdomains using a word list. Hey, I've been given, just for evidence, just for evidence, I have been given the green light to do what I was going to do. Just a little bit of evidence for you there. Yeah, I'm happy about that.
You should always ask permission.
Well, I'm going to go through passive recon first. It's probably better to go through the passive side of things first. Actually, I was going to do go straight into brute forcing. I need to duplicate this display.
So what do we want to find from this?
So we're looking for subdomains. So we've got the domain. You can all the public-facing domains, such as like www.mail. They're the ones that you're going to get through Google anyway. If you search either through Google for a subdomain, which I saw you out to do.
Right, as a hacker or a pen tester.
Yes.
Why is it important to find the subdomains?
Why is it important?
Yeah.
It increases your attack surface. So what you're looking for, the purpose of enumeration or the purpose of DNS enumeration is you're increasing your attack surface. So if you only know the domain for the target, you want to know all the subdomains for the target. Do you see what I'm saying? So,
Targets. More targets.
yeah, so you're looking for more targets. You're looking for a wider attack surface, essentially. So NS lookup. So what we're going to do now is just look at our root servers, or what root servers we are connected to. So we're going to set the type to NS, which is name server. Just type dot and then press enter. That shows us all the root servers that we're connected to. So there's 13 virtual root servers, and virtual root servers is exactly what it means. There isn't actually just 13 root servers in the world. There's millions of root servers in the world, but because the domain system is hierarchical and it's distributed, just like the internet, you're going to see virtual hosts.
And then lookup just gives you the IP of the domain, of the name server you're
Yeah, well, you're getting the host name of it. 2 seconds. So that's just a quick thing, just to look at your root servers if you're ever interested. So you can do that on any machine, just NS lookup. It'll work on Windows, it'll work on Linux as well. It's exactly the same syntax for Linux. So passive reconnaissance. So this is reconnaissance, and you're not actively scanning or querying any domain server. What we're going to do here is just use an online resource which will scan something. So if we scan a website such as, and you expand this little box here, that's going to show us all the subdomains that it picked up. So as you can see, if we go down, observed subdomains, it's got www.nameserver1, nameserver2. What was that fourth one? I can't see that from here. Admin, VPN, support. So yeah, that's one resource is VirusTotal, but there's another resource which I prefer, which is DNS Dumpster. So DNS Dumpster, however, will give you a lovely map as well, which I prefer using DNS Dumpster. I think it works much better.
Go to something very similar.
Yeah, it does, yeah. So again, we're going to go through DNS Dumpster and go through that. If we go down, I can't really see that from there. 2 seconds.
Come on,
Huh? So this is gonna break it up into the types as well. So as on the command prompt, we were looking for name servers. This is going to break it up into which parts of the name servers, which parts of the DNS servers, which part of the mail servers, and then obviously the domains. Good thing about DNS Dumpster is it also compiles stuff that you'd see from like an Nmap scan. So if you're scanning a network and you're looking for like an operating system, stuff like you use a flag to try and detect the operating system based on the response. So on how the service responds, Nmap will tell you potentially it'll have a guess at what the operating system would run. So the good thing about DNS Dumpster is you don't have to do the Nmap scan, and quite a lot of the time it's already compiled in there. So also DNS Dumpster will give you, or it'll attempt to give you some form of map, which is incredibly useful. So again, it's going to tell you, or it's going to attempt to tell you what operating system it's running or what service it's running. So if it's running Apache, it's going to build up a map of it. So what are DNS servers and what are mail servers. So down there, it should say gandhi.net if you can see it. And that's the mail service. You then go to gandhi.net, search for the mail server, something like that. So that's DNS Dumpster. We're going to go through a couple of scans through Kali. Do you all know what Kali is? Kali, no. So Kali is essentially a penetration testing focused operating system based on the Debian distribution of Linux. So it's essentially it's a hacker's operating system. So there is other operating systems. Fedora has Fedora security. Parrot has.
I quite like the Ubuntu.
Yeah. So.
Most of the stuff that Kali runs.
Yeah. So essentially, it's just instead of downloading Linux and then installing everything you need to do penetration testing, it's got everything pre-installed. So all the repositories and everything that you need to do a pen test or hacking in general, it has it already on it. Sweet. So we're going to be using a command called the Horst command, which essentially it's based from DNS. So it's going to give you DNS queries essentially. So if we use Horst, runesecurity.com, again, I'm just going to use my website because I'd rather use my own website than somebody else's. So it's going to give us, it should be showing the mail server as well as the IP address. You can also search for, all the documentation for this is going to be posted on Facebook. So obviously I'm not expecting everybody to remember everything from a day. So everything that I do will be documented, and it's also filmed if you want to watch it back as well. So Horst comes with a lot of additional syntax to probe for certain things, such as name server. So we can go for name server, runesecurity.com. It's going to show us all of the name servers. So that's the Horst file. So what we did there is tac t, so type, and then specify what type we were looking for, so name server and mail servers. I might already...
So if you get stuck, just type in man, Horst, and it'll tell you what the little switches are, those different things.
Yes, exactly, yeah. So we've done name server and mail server. And now what I'm going to do is, so this is where the brute forcing comes into it. So obviously all the stuff that we've showed you so far is obviously the public facing stuff. So if we create a word list, which is compiled of common subdomains, so like, oh god, like www, FTP, mail, proxy, router, admin, firewall, things like that. So we're just going to create that list. Oops. So if we choose, so we'll call it list.txt. Oh, I've already got a list.txt. Save that. So we're going to save that list, and now we're going to use, in a for, do you all know what a for loop is? Yeah, most of you know what a for loop is. So what we're doing is we're going to be using a local variable called subdomain, which will only be enclosed within this loop. So it's only, if anything, if you have a piece of code and you've got another chunk of code here, that variable can only be used in this loop because it's been declared and it's a local variable. So the for loop is going to iterate through everything in the list. So we've got the list, I'll just go through it here, www.ftp, VPN, and so on, everything we've got in there. So it's going to go through each list, so it's going to go host, www. Just you get what it's doing, it's iterating through each one. And then it's going to display it. That part, if obviously there's only 3 people who are going to be doing cybersecurity, but grep, it's going to find a string based on the output. But again, it's going to get too complicated if I explain grep. But, so we'll just stick with the for loop for now. So we're going to run that command. We'll go through our list, go through each one, www.ftp, VPN, see what we can find. So we found www, found FTP, mail. Is that one too? The ones where it's coming up with NX domain, not found. Obviously, because we're not tidying up the output. If it did have the grep part in it, you wouldn't be seeing that sort of stuff. So I'll put it with the grepping. So that's what it's found. But obviously, it's found the ones we don't want as well. So now I'm going to cut those out first. So we're looking for lines which have has address on it. So the ones that don't have has address on it, so grep has address, it's not going to show them in the next output. So as soon as I hit enter, it's not going to show that. The delimiter, what that's doing is we're using space as a delimiter. So every space within these parts here, so space there, that's a delimiter. And then field 1 and 4. So we're only interested in field 1 and 4. So the next output will only display the first field. So it would be first field, space, second field, space, third field, space, fourth field, space. And it's looking for the first field and the fourth field. And it's only looking for lines that have has address in it. So we're running the same command. But again, like what Ed said, we're tidying up the output. We don't need to know the domains we haven't found. And we don't need the irrelevant information. What we need is the subdomain, the domain, and the IP address for that domain. Another thing, we'll go for a larger word list now. We've committed a for loop initialized to the variable, the local variable subdomain. Cat list, I didn't explain what cat did. Cat reads everything in that list. So everything in this list here, it's going to read everything. So that's all cat does. Cat read this list and use that as the local variable. So that list becomes, does that make sense? That list becomes the local variable, and then it's obviously iterating through local variable and grepping.
It's line by line.
Line by line, yeah.
Word once per line.
Yeah, yeah, that's exactly right. And then obviously grep's looking for a specific term, and then cut, we're setting a delimiter, and we're printing only the first field and the fourth field. So that's what that does. Tac F1, comma 4, field 1, field 4, and then we're just saying that the loop's done. So the next thing we're going to do is we're going to go through a bigger word list. So we're going to take, so this is just a bigger word list. So instead of using, say, like 15 subdomains, we're now using like 500 subdomains, I think it was. So we're going to take all those subdomains. So these are all the subdomains that have been found, compiled into a word list. And then obviously I'm using that word list. So I'm going to copy all those domains, go back to Carly, and we'll just call it, we'll call it biglist.txt, because it's a big list. Paste those in there, and we'll save it. And this time, instead of using a small domain, change our list to big list. Huh? No. No, we're going to do that on reverse. So this is forward. So we're taking a domain and turning it into a IP address. The other way is turning an IP address into a domain. The idea is if it's a smaller company, it's a medium-sized company, you might obviously, it depends on what type of footprint you want to leave essentially, but you're not going to be looking for all the niche subdomains, if that makes sense, if it's a small domain. Whereas if it's a huge domain like Google, you want to try a bigger word list because there's going to be more subdomains. Does that make sense? Yeah. So I'm going to go through the automated tools. So the first one is DNS Recon. It has a bunch of switches for it. So we'll go to the man page for that. And DNS Recon. So yeah, we're going to look for domain. So we're going to use TACD, which is for domain. Again, you can supply it with a dictionary file. So what I'm teaching you here is the manual way to do it. Do you know what I mean? So the host command is native to every Linux box. So if you exploited a machine and you wanted to enumerate within that domain, you could use the host command, providing you've got access to Linux. Do you see? Does that make sense? It's coming from inside the domain as opposed to outside the domain, and then you're querying the name server inside the domain. So that's why I'm teaching the host command. And it's useful to know the manual way of doing things. But like I said, from that list, you can just supply DNS Recon with a dictionary file. So I could just tell it to use big word list and go through every list in there. So yeah, DNS Recon, TACD, we'll put in google.com. See what we can find from google.com. So it's found the name servers straight away. So it's going to go through everything, because obviously this is a tool within Kali which is programmed to do its thing. So it's going to be much more sophisticated than the host command. So it's found the name servers. So it doesn't look like Google's blocking me. So again, that's found quite a lot of subdomains. I have no idea.
Or Java? Yeah, Java.
It's found a lot of name servers. Enumerating SRV records. There is ones that will attempt something called the zone transfer. So as I explained on the board, when I was saying the .com zone only dealt with the 13 top level domains, the root only deals with when I was talking about like the hierarchy of domains. Well, that would be a zone. So when there's a zone transfer between two domains, you could enumerate and take that file. So a lot of the time, the records of that zone transfer are located on the server itself. So you can actually, I'm not going to do it here because it is invasive. TACL, there we go, list zone. So if we go host TACL. So we'll take name server 1. Again, do you see how it's adding a dot on the end? Because it's directed to the root. So that's what I was explaining. If you put a dot on the end, it's the same thing. So yeah. Well, you do now. You've learned something, Tom. So that's going to try name server 1 and ask it for the zone transfer file. So when it committed a zone transfer, it would have left information on that zone transfer, which is fantastic for hackers because it's taken all of the subdomains.
What would you get from a zone transfer file?
Everything. So when it was transferred from one zone to another zone, it keeps a log of everything it transferred. Now, a lot of the time when that's done, the person who does it misconfigures it and essentially opens the zone transfer file to anybody who wishes to probe the DNS server.
Inside of that file,
you would get everything in that domain. So every subdomain, your www and your mail, everything, it'll show you everything just from that zone. But that's what I meant about the hierarchical thing. That's why it's like that.
And you're reading a file you're not supposed to.
Yeah, so you read. Yes, it's computer misuse because you're reading a file, exactly.